Hello, my name is Nathan Dreiser. I'm here from Academic Support to help explain to you the ideal gas law and the combined gas law. Um, Hopefully at this point you've had them explained to you already and you know how they work, but a lot of people still tend to get them mixed up on a test or something because it's very easy to not know when to use one or the other. So hopefully that video will help alleviate this. Um, so for the ideal gas law, the way you use the ideal gas law is if you know three of the variables here and you don't know the fourth, then you can use this formula to find that fourth. So for example, let's say you know the pressure and volume and the temperature, but you don't know the number of moles you have. Well, you have the ideal gas law, so you can plug in here and you'll end up being able to solve for n, the number of moles. The combined gas law, on the other hand, is basically a comparison at two separate points in time, right? So if you know what the state of a gas is at one point in time, you can figure out what it is at another point in time. So a very short way to say that is the ideal gas law is looking at a single point in time. The combined gas law is comparing two separate points in time. Now, another quick note that I'd like to mention is that the units between these you can treat them slightly differently between these two formulas. Ideal gas law, the units are basically, they have to be in liters, atmospheres, moles, and kelvins for the most part for this to work. It does work in other units, but this is the most common combination you'll find in chemistry, and therefore tends to be the easiest for the sake of this class. The combined gas law, on the other hand, it doesn't really matter what units you use. The only exception to that is with temperature, you have to use Kelvin. But other than that, you can use any units you want. You can use liters, you can use gallons, you can use atmospheres, or you can use torrs. It doesn't really matter as long as the units match on both sides. So if you use torrs on this side for pressure, you have to use torrs on the other side for pressure. And then the last thing I want to mention about this before I get into a practice problem is the combined gas law actually replaces those other smaller gas laws that they teach you very early on in this chapter. So Charles' law, Boyle's law, Gay-Lussac law, Avogadro's law, those tend to be made irrelevant by the combined gas law because the combined gas law, as is sort of hinted in the name, combines them all to make one big gas law. Now we'll get into a practice problem to sort of demonstrate what I mean by these. Okay, so let's say we have an initial pressure of 460 torr and an initial volume of 5 gallons. Okay, if the volume changes to 3 gallons, what will be the new pressure? So the first thing I want to mention, the first thing you always want to do with these type of problems is think about which of these two laws you want to use here. All right. So it sort of gives it away by the way I wrote out the variables, which is something I always suggest you do when you're solving a numerical problem, is write out the variables you know. So it sort of gives away that I'm going to be working with the combined gas law. But the way you want to think about this on your own is the reason I'm using the combined gas law is because of the word change, right? It said if the volume changed from 5 gallons to 3 gallons. Because there's a change, you use the combined gas law. If there wasn't a change, you'd use the ideal gas law. There is a change, so we're using combined gas law, meaning let's write that out. P1V1 over N1T1 equals P2T2, V2, my bad, V2 over N2T2. Now, another thing I want to mention it didn't really talk about the number of moles and the temperature. A lot of the times problems will do this. What that means is that those variables aren't changing. Now, if those variables aren't changing, that means that they're the same number as each other. And if they're the same, we can cancel them out on both sides, right? So the temperatures are the same and the number of moles are the same. They cancel out, meaning we're left with just this right here. P1 V1 equals P2 V2. Okay? Now, remember what we're solving for. We're solving for pressure 2. So let's divide both sides by volume 2 to get pressure 2 all by itself. Okay? Divided by V2, divided by V2, we end up with pressure 2 is equal to this right here, because these two cancel out. So P1 V1 over V2 is what we have left on that side. Okay? Now we plug in our numbers. Pressure 1, what was that? That was 460 torr. 460 torr. Volume 1 was 5 gallons. Okay. And then volume 2 was 3 gallons. Now, if you plug this into a calculator, what you're going to get is 767 torrs. Okay, so that's how you'd use the combined gas law. And now I want to walk through a few things to sort of clarify some of the points up here. First thing I want to mention is the units, right? I intentionally used weird units. I use torr and I use gallon, not very common units, but it still works with the combined gas law. Again, want to reiterate, the only units that do not work with the combined gas law are temperature. Temperature has to be in kelvins. That's the only exception. Okay? And then I'd also like to mention, if you take a look at this, you notice that once we canceled things out, we ended up with Boyle's law right here, right? P1 V1 equals P2 V2. So this is what I mean by the combined gas law is just a combination of all the other gas laws, all the smaller ones. If you know the combined gas law, you don't really need to know those other ones. So it makes these problems a lot easier. You only need to know two things, the ideal gas law and the combined gas law. Now, that's basically the gist of it. Hopefully that was helpful for you to determine which gas law to use in different situations. And that's about it. I hope you enjoyed.